Okay, so I'm going to do problem 3. This is finding the tangent plane to a surface. Now, when I did a similar problem on Dr. Yaskin's test, I did it one method. I'm going to do it another method here. So the idea is that the equation for the tangent plane, so if you have z is equal to f of xy, and you want to find the tangent plane at a point, then the tangent plane is just z is equal to f of x0, y0 plus the gradient of f evaluated at x0, y0 dotted with x minus x0, y minus y0. And another, this right here, this is just z0. And this is x0, this is y0, this is z0. Okay, this is just one of the formulas that we saw. You can look back at the previous lecture notes to see where this lecture, or to see where this formula comes from. Or just think through it, that's even better. Okay, so this z equals f of x naught y naught, that's z naught, so that's 1, plus the gradient of f evaluated at x naught y naught. So the gradient of f is, it's going to be the x derivative and the y derivative. So the x derivative is y cosine xy. So y is pi over 2. Now it's going to be times cosine of xy. That's 1 times pi over 2. Well, cosine of pi over 2 is 0. So that's 0, comma. Now the y derivative of f is x cosine yx. So x is 1. But again, cosine of pi over 2 is 0, dotted with x minus x naught, which is 1. Comma, y minus y naught, which is pi over 2. And of course, this right here is just 0 because this is the 0 vector. Since this is the 0 vector, the dot product of this and that is equal to the 0 vector, or equal to 0. So this is just equal to 1. So in this problem, the tangent plane is very simple. It's just z is equal to 1. Okay, I have enough time in this video to go on ahead and do this problem. So this is problem 3, part 1. This is problem 3, part 2. And again, we're just going to use the same formula. This is z is, so the tangent plane is z is equal to z naught plus the gradient of f evaluated at x naught, y naught, dotted with x minus x naught, y minus y naught. Okay, and I'm going to go ahead and compute the gradient down here so I don't get too confused. So the gradient of f, the first component is the x derivative. So this is 2x minus y. The second component is the y derivative. So this is 2y minus x. Okay, and now I can plug it in up here. So then the tangent plane is z is equal to z naught. Remember, this is z naught. So this is 1 plus, and x naught and y naught are also 1. So this is going to be plus the gradient of f evaluated where x is 1 and y is 1. So this is 2 minus 1. That's 1. This is 2 minus 1. That's 1. Dotted with x minus 1, y minus 1. And really, you should just expand this out unless there's a reason not to. So this is 1 plus x minus 1 plus y minus 1. And let me just write the z here again. And so this is the final answer. This is the tangent plane to the surface at the given point.